Synchronous transfer is used by the VFD to start multiple motors and transfer them across the line. It allows for a soft start that provides very little stress to the power grid, ensuring that your operation is compliant with local regulations. The Siemens SINAMICS Perfect Harmony air-cooled and water-cooled VFDs use a superior closed transfer approach for a bumpless transition, which eliminates the risk of motor, pump, or shaft damage during startup. In this video, you will learn how synchronous transfer works and how the SINAMICS Perfect Harmony makes the transition smooth and problem-free. Performance tests will be conducted on a Perfect Harmony drive at our facility in New Kensington, Pennsylvania. Synchronous transfer is typically used in applications where pumps, motors, or compressors are placed in series. The system operates as shown in this diagram. Here you see the main PLC controller. The PLC controls the VFD and switchgear containing two contactors, a VFD isolating contactor and a full-voltage line starting contactor. In this demonstration, the VFD is controlling multiple motors. Generally, the application requires the use of a VFD to start the motor. Once the motor is at full speed, the VFD will synchronize the motor voltage to the incoming line voltage by matching the frequency of the motor to the incoming line. By adjusting the speed of the motor, the waveforms are synchronized, and the motor will then be transferred across the line. The system's main controller closes contactor B1, which attaches motor M1 to the VFD. Motor M1 can now be operated at variable speeds and meets process requirements. If motor M1 driving pump 1 cannot keep up with the process requirements, the VFD is likely operating at full speed. The system synchronizes motor M1 voltage to the incoming line voltage until the voltages are perfectly balanced and in phase. Once that has occurred, contactor L1 is closed and the motor is transferred from VFD operation to the incoming line. This is a closed transition, or bumpless transfer. The VFD is now connected to motor M2 by closing contactor B2. Motor M2 can operate at variable speeds and meet process requirements with M1 running across the line. The across-the-line transfers can also be done in a reverse direction. If we no longer need two motors or pumps running, the VFD commands motor M2 to 0 speed and then opens contactor B2. The VFD output is synchronized to the incoming line, and contactor B1 is closed. Motor M1 is transferred from the line back to the VFD output and is now running on the VFD at variable speed. The specific control of synchronous transfer can be demonstrated using the Siemens Tool Suite software. This specialized troubleshooting and monitoring software package is based on the standard NXG2 software tools. Looking at Tool Suite, the purple trace represents the drive operating speed, while the yellow trace illustrates the amount of motor torque current. The red trace is the up transfer operating state, and the green trace represents the motor speed, which is being run at approximately 90% rated speed. The drive is given an up transfer request as shown by the rising edge of the purple trace from run state to up transfer. The VFD output accelerates the motor to 100% line frequency and achieves phase and frequency lock at 60 Hz. Once synchronized, the up transfer state generates a request to close the line contactor, connecting the VFD output and motor to line. When the line contactor is closed and acknowledged, the VFD contactor is opened and the VFD is disabled. The down transfer sequence is almost identical to an up transfer. The motor will be taken off the line and connected to the VFD for variable speed operation. The drive is turned on and, as shown in the trace, is ramping up to 60 Hz. No torque is appearing yet because the current is being provided from the line. The light blue trace represents the down transfer state. In the second stage of the down transfer process, the down transfer request is received and the VFD enters down transfer mode, as seen in the purple trace. The VFD output connected to the line and motor achieve frequency and phase lock with line voltage sensed at the VFD output. Once synchronization is achieved, a request to close the line contactor is generated. The line contactor closes and is acknowledged. At this point, the VFD begins to take control of the motor, as seen by the generation of torque in the yellow trace. Now the VFD is supplying power to the load, and the line can be disconnected from the motor. The VFD then issues a signal that the bypass contactor L1 can be opened and the VFD has control of the motor. The down transfer request is then removed and the VFD is in control of the motor. The same test is repeated while monitoring the motor. The scope trace will show the output drive voltage and the line voltage feedback at the same time. When the drive is started, the VFD will ramp up to 60 Hz and synchronize the two waveforms. Here, the drive has been started and the output frequency of the drive ramps up to 60 cycles. A transfer request flag is set, and the output of the drive frequency synchronizes with the line. Once the drive output and the line are within 1.5 degrees of phase with each other, the VFD will transfer the motor to the line and the VFD will be commanded off. The motor has been transferred from the VFD to the line. Closed-loop synchronous transfer is just one of the many benefits offered by the Siemens SINAMICS Perfect Harmony VFD. To learn more about our drives and their patented features, please watch the videos in the Tour the Drive section of this toolkit.